So after considering that fact that this part is very larger than the rest of the piece for a very good conductor, so we can find the value for A and B by putting these values, and we get A is equal to B is equal to under root mu sigma omega by 2. So over here we can get the general solution, and amplitude becomes E naught e to the power minus AR, with this part is the amplitude. So when we say that okay, the amplitude of the wave is there when the wave is moving in any medium, so there is a factor known as you can say the skin depth or depth of penetration, up to which the wave, or you can say the wave can propagate with the proper manner. After that there will be exponential decrease in the amplitude, and you can say that overall wave propagation will be very difficult in a medium. So that distance up to which the maximum amplitude reduces to 1 by E times of its original value. How you will define the original value? When an electromagnetic wave hits the surface of any material, any medium, then at the just before hitting the surface, whatsoever be the is value, amplitude value, that will be the maximum value, and when it enters the material in medium, it starts reducing, amplitude starts reducing, and whatsoever the distance up to which the amplitude becomes 1 by E times of that value at the surface, that distance is known as skin depth or depth of penetration. So we can define it easily that when amplitude becomes 1 by E times of E naught, then that distance R is called skin depth or depth of penetration. So the value of depth of penetration we can easily find by putting the value over here, the amplitude, where it becomes 1 by E times of the maximum, and E naught e to the power minus AR. So if we solve it for A, we get A is equal to 1 by R, or R is equal to 1 by A, right? So this value of A we have over here under root mu sigma omega by 2. So this we can use here. So the skin depth value we can easily find that it is actually under root of twice mu sigma omega, which is denoted by delta. This is a very important part, the skin depth or depth of penetration. What is the physical significance of skin depth? You can say, you can already see that omega is the frequency of the wave. So if the wave frequency is very high, the skin depth value will be very low. It shows that for an electromagnetic wave moving in any medium, or the good conductor is there, so if the high frequency electromagnetic wave moves, then it cannot propagate to a very large distance, first of all. Second, the large value of skin depth, if you can say you are provided with a value which will be a very large, very big value of skin depth, so you can easily make out that that conductor is actually providing very less attenuation for the wave. Less attenuation means the loss of energy is very less with respect to the position, with respect to the distance covered, that you can say. So this is the physical significance, very important part of this topic. After covering this part, you can easily make out that we have discussed the solution for electromagnetic wave, the solution for Maxwell equations, for a very good conductor, for dielectric media, for lossless medium, and we got the values for absorption coefficient, we got the value for A and B, and we have found you can say expression for skin depth also. I hope you can understand the skin depth physical significance also, and I request all the students to please look into this video twice or thrice to understand properly, and try to do the derivation as far as possible by yourself using pen and paper separately. At least devote 15 to 20 minutes time for this particular topic. It's a very important one. The next topic what we will deal with, the electromagnetic energy density. along with Poynting vector and Poynting theorem. Okay, that's all for today. Thank you.